How many grams of carbon tetrachloride are produced when 5.78 grams of chlorine reacts with excess carbon disulfide, assuming an 80% yield? First, take a moment to recognize that the equation is already balanced. Never assume an equation is balanced. Always check for a balanced equation. We are told that carbon disulfide is the excess reactant. Therefore, chlorine must be the limiting reactant. So we don't need to solve for the limiting reactant. Next, we want to find the mass of the product assuming an 80% yield. I explained yields in an earlier video. Here is the equation. Our strategy is going to be to solve for the theoretical yield, or 100% yield. And we know the percent yield from the problem. So we can rearrange to solve for the actual yield. I'll use the limiting reactant chlorine and convert to carbon tetrachloride. To do this, I'll need to convert the moles of chlorine to the moles of carbon tetrachloride. And I can do this by using the mole-to-mole ratio from the balanced equation. But notice, the moles of chlorine are not provided. Rather, we begin with the mass of chlorine and are asked for the mass of the product. For these problems, we need to convert the grams of chlorine to moles of chlorine using chlorine's molar mass. Once in units of moles of chlorine, we can convert to moles of carbon tetrachloride using the mole-to-mole ratio. Then we can convert moles of carbon tetrachloride to grams of carbon tetrachloride using the molar mass of carbon tetrachloride. So here it is. I'll convert 5.78 grams of chlorine to moles of chlorine using the molar mass. Then I'll use the mole-to-mole ratio from the balanced equation to convert moles of chlorine to moles of carbon tetrachloride. And finally, convert moles of carbon tetrachloride to grams of carbon tetrachloride using carbon tetrachloride's molar mass. 4.18 grams is the theoretical yield. Again, this is assuming a 100% yield. But recall that the question was asking for an 80% yield. So I'll take our percent yield equation and rearrange to solve for the actual yield. Inserting our values gives 3.34 grams of carbon tetrachloride, assuming an 80% yield.